Mathematics 10 Module 1, Week 1 and 2.
Good day everyone, I am Teacher Beth and I will be your math teacher for the whole school year. Welcome to the first quarter of our Math 10 class. Our first lesson is all about sequences and arithmetic sequences. At the end of the lesson, you are expected to know 1. Identify and generate patterns. 2. Find the end term of a sequence and general terms of a sequence. 3. Illustrate an arithmetic sequence. 4. Determine the end term of an arithmetic sequence. 5. Find the arithmetic means and sum the terms of a given arithmetic sequence.
Summary of topics. Lesson 1. Patterns in Algebra. 1.1 Sequences and Series. 1.2. Nth term of a sequence. 1.3. General term of a sequence. Lesson 2 Arithmetic sequence in arithmetic series. 2.1 Arithmetic sequence. 2.2 Nth term of an arithmetic sequence. 2.3 Sum of the first n sequence terms of an arithmetic sequence. 2.4 Arithmetic mean. Objectives. At the end of the session, the students should be able to 1. Identify and generate patterns. 2. Find the nth terms of a sequence and general terms of a sequence. 3. Illustrate an arithmetic sequence. 4. Determine the nth term of an arithmetic sequence. 5. Find the arithmetic means and sum of the terms of a given arithmetic sequence.
So do you remember what a pattern is? Remember the picture patterns? Well, a pattern is any group of objects or numbers that follow a rule. So we see the pattern with the red circles. And what we're doing is adding on one centerpiece and one to each end each time. So the pattern is growing. Or you see the pattern with the round circles that look like we're making bowling alley pins all set up. Or it could be making a pattern with numbers. Whatever we do, there's going to be a rule. So when I talk pattern, remember, I'm talking about finding a rule. In your notes, you can see that I have a pattern started. 1, 4, 6, 16, 64. So if we were going to look for that pattern, what am I doing each time I go to a different number in that pattern? This is where your calculator can be helpful. I'm going from 1 up to 4. I could be adding 3, but if I do 4 and add 3, I'm not going to get 16. So I don't think I'm adding. So let's try multiplying. 1 times 4 does equal 4. 4 times 4 is 16. Now I'm seeing a pattern. 16 times 4 is 64. And I need to get my calculator out to figure out the next one. So I tapped it into my calculator and I've got 64 times 4, 256. And if I want to find the next number in that pattern, I will do 256 times 4, which is 1024. And I could continue on my pattern that way.
Let's have first an activity. So ang gagawin natin, aalamin natin kung ano yung mga susunod na letters or numbers. Okay, so for number 1, I have A, D, G, and J. So ano kaya yung mga susunod na letters? We have M, P, S. What is the pattern? We will skip 2 letters. Next, For number 2, I have 1, 3, 5, 7. What is the pattern? These are numbers that are odd. So therefore, what's next for 7? We have 9, 11, and 13. For number 3, we have 1, 4, 9, 16, and 25. What are these numbers? Or what do you think is the pattern? So these numbers are all perfect squares. So what is next to 25? We have 36, 49, and 64. Number 4, we have 5, 15, 25, and 35. What do you think are the next numbers? So we have 45, 55, and 65. What is the pattern? We will just add 10 from the previous number. So 5 plus 10, 15 plus 10, 25 plus 10, 35 plus 10, 45, and so on and so forth. And then for number 5, we have 1, 3, 6, 10. We have 15, 21, and 28. What is the pattern? We will add 2 from 1. So 1 plus 2, that is 3. 3 plus 4, that is 6. 6 plus 4, we have 10. So therefore, we will add 5 to 10. And that makes it 15. And then plus 6, 21. Plus 7, 28. So, yung mga inad natin, plus 2, plus 3, plus 4, plus 5, plus 6, consecutive numbers. Okay. So, a sequence is a function whose domain is the set of positive integers. It also means an ordered list of numbers. We have two kinds of sequences. A sequence is infinite if its domain is the set of positive integers without a last term. So, kapag may nakita kayong 3 dots or ellipses, yan ang magsasabi sa atin that the sequence is infinite. While a sequence is finite if its domain is the set of positive integers which has a last term or sometimes it is represented by n. So kung mapapansin nyo, meron siyang last term. That is a finite sequence. Now, each number in a sequence is called a term. Ano ba ang term? Halimbawa, I have 5, 10, 5, 15, 25, 35, and 45. So, pag sinabi nating term, ito yung first term, second term, third term, fourth term, and fifth term. So, how many terms do we have? We have 5 terms. Now, remember that your n is represented by the order. Yung n natin, yan ay order nung terms natin. Hindi yan yung mismong number na ang ilalagay natin ay yung 5, 15, 25, 35, and 45. Hindi yun. It's the order. It's 1, 2, 3, 4, 5. In the sequence 1, 3, 6, 10, 15, we can denote that the terms as follows. So, A sub 1, yung 1 na to, that is first term. So, what is our first term? That is 1. A sub 2 means A sub 2 second term. That is 3. A sub 3, that is your third term. So, that is 6. A sub 4 is 10. And A sub 5 is 15. Siya yung panglimang term dun sa sequence. Now, what if tinanong ka, what is the 20th term? What is the 19th term? So, paano natin siya kukunin? Diyan tayo gagamit ng general term o yung tinatawag nating rule. So, itong term na to, general term na to o rule, ito yung pwede natin gamitin para makuha natin yung mga susunod na terms, lalo na kung nasa malayo na sila. So, let us prove first kung tama ba tong rule na to. So, halimbawa, I have A sub 1. So, a sub 1 means first term. Tingnan natin kung talagang ang nasa first term ay 1 using this rule. So, 1 is equal to 1 half. And then, we will add this 1 plus 1. So, that will become 2. So, you may cross out or cancel. So, 2 and 2, that makes it 1. So, 1 times 1, that is 1. So, our first term, a sub 1 is equal to 1, which is correct. Next, a sub 3 means our third term. So, we will substitute again 3 to all of the n variables. So, we have a sub 3 is equal to, from n over 2, that will become 3 over 2, and then n plus 1, that will become 3 plus 1, because we are referring to the third term. Okay, so we have add 3 plus 1, that will become 4. And then 4 divide 2, that makes it 2. 2 times 3 is 6. For a raised to 5, so a raised to 5, fifth term. Let's check if it's really 15. So substitute 5 to all n. So we have a sub 5 is equal to 5 over 2 for n minus over 2. And then 5 plus 1 for n plus 1. So we will add 5 plus 1, that will become 6. Pwede rin namang mag-multiply ka muna. 5 times 6, 30, divide 2, that is 15. Or pwede ring 6 divide 2, magko-cross tayo, that is 3. 3 times 5, that is still 15. For a sub 2, we have yung second term. So 2 divide 2 times the quantity of 2 plus 1 equals 3. Let's see. 2 plus 1 is 3. 3 times 2 is 6. Divide 2, that is 3. So our second term daw is 3, and that is correct. And then a sub 4, we have 4 over 2 times the quantity of 4 plus 1. 4 plus 1, that is 5. Times 4, 20 divide 2 is 10. And a sub 4 is equal to 10. Okay. So, find the first 5 terms of the sequence whose general term is given by a sub n is equal to the quantity of n minus 3 raised to n. So, dito, kukunin natin yung first 5 terms. So, yung unang 5 terms, ano kaya yon? So, binigay yung general term. Let's try to solve. So, given yung formula na or rule na a sub n is equal to the quantity of n minus 3 raised to n. So, magsa-substitute tayo ng 1 doon sa mga n since ang hinahanap natin ay first term. So, first term ang hinahanap. So, ang ilalagay natin sa mga n na yan ay 1. So, let us solve 1 minus 3. That will become negative 2. And negative 2 raised to 1 is negative 2. That will be our first term. Next, our second term. So, since second na ang hinahanap natin, isa-substitute natin ang 2 sa mga n. So, we have now 2 minus 3, that is negative 1. And negative 1 raised to 2, that is 1. So, since negative 1 times negative 1, same sign, that will become positive 1. Next, for the third term, we are looking for the third term. So, we will substitute 3 sa mga n. So, 3 minus 3, that is 0. And 0 raised to 3 is 0. For our fourth term, we have 4 minus 3, that is 1. And 1 raised to 4 is positive 1. And for our fifth term, so we have 5 minus 3, that is 2, and 2 raised to 5 is 32. So we now have the first 5 terms of the general term a sub n is equal to the quantity of n minus 3 raised to n. We have negative 2, 1, 0, 1, and 32. Next, find the first 4 terms and the 20th term of the sequence whose general term is given by a sub n is equal to the quantity of negative 1 raised to n over 2n minus 1. So, ito na yung sinasabi ko. We really need the general term or yung rule natin kasi may cases na pang 20th term yung tinatanong. So, paano natin siya makukuha ng mas mabilis? With the help of the general term. So, let's solve. So, for the first term, so ang una natin gagawin, substitute natin yung 1 sa lahat ng n. Ayun siya. So, we now have negative 1 raised to 1, that is still negative 1. And then, substitute 1 to 2n. So, we have 2 times 1, that is 2, minus 1, that is 1. So, negative 1 over 1, that is negative 1. For our second term, substitute 2 to all of our n. So, we now have 1/3. For our third term, we will substitute 3. So, we have negative 1 raised to 3. That makes it negative 1. And then, 2 times 3 is 6. 6 minus 1, that is 5. So, we will now have negative 1/5. Next, for our fourth term. So, substitute 4 to n. So, negative 1 raised to 4, that is positive 1. Now, remember, if our exponent is an even number, the product is positive. But if our exponent is an odd number, the product is negative. And then, let's go back. 2 times 4, that is 8. 8 minus 1, that is 7. So, we now have 1 over 7. Now, let's find out the 20th term. Okay. So, the 20th term, we will substitute 20. So, negative 1 raised to 20, since 20 is an even number, therefore, the product is positive 1. And then 2 times 20, that is 40, minus 1, it's 39. So, the 20th term is 1 over 39. Now, remember that if you have the quantity of negative 1 raised to n, this is the general term that causes the signs of the terms to alternate between positive and negative. So, kapag nakita natin tong negative 1 raised to n, yan ang palatandaan natin na ang terms natin ay magiging alternate ang signs. So, kagaya nitong example na to, kung mapapansin nyo, negative, positive, negative, positive. Why is it positive? Because, since 20th term siya, kung mapapansin nyo, yung second term natin at fourth term ay even numbers, also 20. So, ibig sabihin, lahat ng nasa even number natin na term ay positive. Okay, now, baliktad naman tayo. So, given ang sequence, we will find out the general term or the rule. So, I have here 1, 8, 27, 64, and 125. What do you think is the general term? Okay, so all of these numbers are the cube of the numbers. So, this will become a sub n is equal to n raised to 3. Halimbawa, 1. 1 raised to 3 is 1 times 1, 1 times 1, that is still 1. And then 2, 2 times 2, 4 times 2, that is 8. That's why it's n raised to 3. Next, I have 1, 1/2, 1/3, 1/4, 1/5. So, what do you think is the general term? Okay, kung mapapansin nyo, the denominators just increase consecutively. So, nag-i-increase lang siya na magkakasunod. Pag sinabi natin consecutive, magkakasunod. Okay? So, therefore, the general term is a sub n is equal to 1 over n. Kung ano yung term niya, kung pang ilang term siya, that is the denominator. Next, I have negative 5, 10, negative 15, 20, and negative 25. So what is the general term? So kung mapapansin natin, itong mga numbers na to ay multiples of 5. Now, take note. Kung mapapansin natin, ang signs niya nag-alternate. So ano nga yung sinabi ko kanina na gagamitin kapag ang signs natin ay nag-alternate? We will use the quantity of negative 1 raised to n. Now, since multiple siya ng 5, ita-times lang natin siya sa 5n. Next, I have 1, 4, 9, and 25. So, the general term is, what are these numbers? These are all perfect squares. So, therefore, our general term is a sub n is equal to n raised to 2. Next, I have 3, negative 6, 9, negative 12, and 15. What is the general term? So, nag-alternate na naman siya. So, we will be using negative 1 raised to n minus 3n.
Sequences. A number sequence is a list of numbers having a first number, a second number, a third number, and so on. A sequence may be generated from shapes, pattern, or rules. The number of dots generate the sequences of the figure numbers. Each number is sequence is called term. Each term is identified by its position in the ordered list. The terms are usually denoted by A1, A2, A3, and so on, or T1, T2, T3, and so on. Example: the ordered list of numbers, such as triangular numbers 1, 3, 6, 10, 15, and so on. Square numbers 1, 4, 9, 16, 25, and so on. Pentagonal numbers 1, 5, 12, 22, 35, and so on. The sequence of triangular numbers 1, 3, 6, 10, 15. The first term T1 equals 1. The second term T2 equals 2. The third term T3 equals 3. The fourth term T4 equals 4. The fifth term T5 equals 5.
A sequence having a finite number of terms is called finite sequence. These sequences have a limited number of items in them. For example, our sequence of numbers up to 10 is a finite sequence because it ends at 10. We write our sequence with curly brackets and commas between the numbers like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A sequence that has an infinite number of terms is called infinite sequence. An infinite sequence is a list of string of discrete object, usually numbers, that can be paired off 1 to 1 with the set of positive integer s 1, 2, 3, so on. For example, n equals 0, 1 to 3, so on, and s equals 1, 1/2, 1/4, 1/8, so on 1/2 n. Example 1. Terms of a sequence. Find the next two terms of each sequence. 8, 5, 8, 11, 14, so on. C7, 14, 28, 56, so on. B, 15, 7, -1, 9, so on. D, 24, -12, 6, -3, so on. Solution: 8 in the given sequence, 5, 8, 11, 14, so on. The term is obtained by adding +3 to the previous term. Fifth term, 14 plus 3 equals 17. Sixth term, 17 plus 3 equals 20. B. Observe that in the sequence 15, 7, -1, -9, so on, the term is obtained by adding -8 to the previous term. Thus, the fifth term, -9 plus -8 equals -17, and the sixth term, -17 plus -8 equals -25. C. In the sequence 7, 14, 28, 56, so on, the term is obtained by multiplying the previous term by 2. Thus, the fifth term, 56 times 2 equals 112, and the sixth term, 112 times 2 equals 224. D. In the given sequence 24, -12, 6, -3, so on, The term is obtained by multiplying the previous term by -1/2. Fifth term, -3 times -1/2 equals 3/2. Sixth term, 3/2 times -1/2 equals 3/4. For example, 2 terms of a sequence. The diagram shows 4 patterns. Let the length of a matchstick equal to 2 centimeters. M sub n represents the number of matchsticks in the nth pattern, and P sub a the perimeter of the pattern. 8. Complete the following table. B. Find M sub 5. C. Find P sub 5. Solution. 8. Observe that 5 matchsticks are added to the first pattern. To get the second pattern, M sub 2 equals 7 plus 5 equals 12. Perimeter of the second pattern equals 2 plus 2 times 2 times 2 equals 16 centimeters. P sub 2 equals 16. Thus, we can complete the table as follows. B. Since the next term is obtained by adding 5 to the previous term, M sub 5 equals M sub 4 plus 5 equals 22 plus 5 equals 27. C. Since we observe that the next term is obtained by adding 4 to the previous term, P sub 5 equals P sub 4 plus 4 equals 24 plus 4 equals 28. Sequences are usually given by stating their general or nth given term. As an example, let us consider the sequence given by a sub n equals 3n plus 2. The first 5 terms of the sequence are: the sub 1 equals 3 times 1 plus 2 equals 3 plus 2 equals 5. The sub 2 equals 3 times 2 plus 2 equals 6 plus 2 equals 8. Sub 3 equals 3 times 3 plus 2 equals 9 plus 2 equals 11. The sub 4 equals 3 times 4 plus 2 equals 12 plus 2 equals 14. And sub 5 equals 3 times 5 plus 2 equals 15 plus 2 equals 17. The first term of the sequence is 5, the second term is 8, the third term is 11, and so on. The sequence also be donated as 5, 8, 11, 14, 17. For example 3. Terms of a sequence. List all the indicated terms of each finite sequence. A sub n equals 3n squared minus 1 for 1 less than or equal to n, and less than or equal to 5. B. The sub n equals 1 divided by n plus 1 for 1 less than or equal to n, and less than or equal to 4. Solution. 8. Using counting numbers 1, 2, 5 or n into n squared minus 1, we get the sub 1 equals 3 times 1 squared minus 1 equals 3 minus 1 equals 2. The sub 2 equals 3 times 2 squared minus 1 equals 12 minus 1 equals 11. The sub 3 equals 3 times 3 squared minus 1 equals 27 minus 1 equals 26. The sub 4 equals 3 times 4 squared minus 1 equals 48 minus 1 equals 47. The sub 5 equals 3 times 5 squared minus 1 equals 75 minus 1 equals 74. The 5 terms of the sequence are 2, 11, 26, 47, and 74. B. Using the counting numbers 1 to 4, we get the sub 1 equals 1 divided by 1 plus 1 equals 1/2. The sub 2 equals 1 divided by 2 plus 1 equals 1/3. The sub 3 equals 1 divided by 3 plus 1 equals 1/4. The sub 4 equals 1 divided by 4 plus 1 equals 1/5. The 4 terms of the sequence are 1/2, 1/3, 1/4, and 1/5. For example, for 10th term of a sequence, find the 7th term and the 10th term of the sequence, which 10th term is given by a sub n equals 1 over n plus 1 times n plus 2. b sub n equals n times n plus 1 over 2. Solution. Substitute 7 and 10 in the given rules. 8. A sub 7 equals 1. 7 plus 1 times 7 plus 2. 1 over equals 8 times 9 equals 1 over 72. A sub 10 equals 1 over 10 plus 1 times 10 plus 2 equals 1 over 11 times 12 equals 1 over 132. B sub 7 equals 7 times 7 plus 1 over 2 equals 7 times 8 over 2 equals 28. b sub 10 equals 10 times 10 plus 1 over 2 equals 10 times 11 over 2 equals 55. If the terms of a sequence are known, and we want to write the formula that will produce those terms, it is often possible by examining the terms and looking for a pattern. Such a process depends on insight, and on a trial and error method. The first term corresponds to n equals 1, the second term corresponds to n equals 2, and so on. The sequence of 3, 5, 7, 9, 11 is the set of all integers that starts with 3. Since n represents the set of natural numbers, we must express the sequence in terms of these values of n. The second term must be 5, not 4. An odd integer is always 1 greater or less than an even integer, giving the following. Upon inspection for n equals 3 for 5, so on the trial confirms that n equals to n plus 1. In the infinite sequence 1, negative 1 divided by 8, 1 divided by 27, negative 1 divided by 64, so on the signs alternate. To obtain the alternating signs, we use powers of negative 1. Because any even power of negative 1 is positive, and any odd power of negative 1 is negative, we use negative 1 raised to n plus 1. The denominators are the cubes of positive integers: 13, 23, 33, 43, so on. Thus, the n term of this infinite sequence is given by the formula the sub n equals negative 1 raised to n plus 1 divided by n cubed. We will now generalize the pattern or write the general term when the first few terms of the given sequence are linear or quadratic in nature.